Hi guys and welcome to this live session by Intellipaat. So the topic on our hands today is Kubernetes. So we're going to be discussing few basic concepts of Kubernetes, the architecture of Kubernetes, have a overview look on it and a little bit of insight on it, and then jump on to the actual Kubernetes EC2 instance service that we have created and just work on a few hands-on, create some pod services and see how that happens. But before we get into all of that, please subscribe to our channel to never miss an update from Intellipaat. So let's talk about today's agenda real quickly. So we'll be beginning with a very basic introduction to Kubernetes, why Kubernetes even came about, what is Kubernetes, what it is all about. From there, we'll move on and talk about the architecture of Kubernetes, where we'll discuss the master components, the CI components, and how it looks, the entire structure of it. Once we have that in the bag, we'll discuss about a few basic concepts of Kubernetes, which is very important for you to learn in order to go ahead and work with it. And the concepts that we learn in the third section, we'll try to create those things in the hands-on section, which is the fourth section of our session. So that is about the agenda, guys. I hope that is very clear to you. So without wasting any further time, let's just get into the session. So introduction to Kubernetes. So what is Kubernetes? So to get why Kubernetes is in place, let's dig back in time a bit and talk about the architecture alone, right? So there are three phases of deployment as we talk about in today's scenario. So there is a traditional deployment, there's a virtualized deployment, and there is a containerized deployment. So in olden times when there was not so much force behind the computing powers that we have as today, people used to deploy their websites and everything and all of their architecture, whatever was there on the internet, through their own hardware, their operating system, and the application is there itself. It's running itself. It's there. It's using the actual resources which are present. There is no partitioning, and the system is very cost inductive because you have for every single thing you have to buy a lot of hardware and work with it, and it creates a lot of problem, right? That is not very feasible. So and in this scenario, the operating system, the division of resources is not very optimal. So if my app 1 is consuming a lot of resources, then my app 2 might be getting hurt because of that, because the segregation of resources is also not well balanced. So to tackle this problem, people came about a new idea, a new way to look at things. They came up with this idea which is called as a virtual OS or a virtual machine, something like that, something which can be built on top of your current OS, and you can have multiple virtual instances on top of your current OS, and you can have their own set of resources so that the applications which are inside these different virtual machines, they are not affected by one another. So that was the idea behind it. And so the virtualized era had different virtual OS. There was a hypervisor which will divide the resources and do all the stuff like that. And you can have two separate apps running on two separate virtual machines on their own environment, but running on one particular hardware itself. So it's like having two OS which are running on this virtualized hardware, and hypervisor is responsible for that. So it is something a much more optimized approach. So you can have segregated apps in different environments, and since they are not connected to one particular point for resources, they do not have any interaction between them, and that allows basically for more security and more robustness in terms of that, and better distribution of resources as well. So this was virtualized environments, but the problem with this was it was heavily being used, but the problem is the fact that it still requires a lot of hardware and it's taking a lot of space, and virtual OS itself takes about 4 5 6 GB depending on it, what kind of the OS is that you are going for. So that is something which is a huge problem, right? Because having your resources not fully used, because for making some deployments you do not need a lot of resources which an virtual OS brings about. You do not need a lot of things, and it is very heavy. So people moved on to these things called as containers. Now what is containers? Containers are very portable runtime environment. So it has an OS and it has all the necessary libraries for you to run different things, but it is very very lightweight. So it's like 80 MB, 90 MB, 100 MB, something like that. It's very lightweight, so you can have it running everywhere, and it does not consume a lot of space and works like an independent OS. So that is something which was very helpful. So people started using containerized deployments. Now the thing was, a lot of different kinds of containers were created for different applications. Now what this brings about is a challenge of having multiple containers running across and nowhere to manage it. And this is where Kubernetes comes into the picture. Because you have so many containers, you need something to orchestrate those containers, right? Something that manages it from one place, so one source of handling everything. So that is where Kubernetes came into picture. So Kubernetes is a portable, extensible, open source platform for managing containerized workloads and services that facilitates both declarative configuration and automation at the same time. It has large, rapidly growing ecosystem, and the Kubernetes services, supports, and tools are widely available. It has a very active community base, which is working on it constantly, and they are very responsive in answering your queries as well. So it is something which is very widely used. Big companies like Amazon and we'll be doing on their own service, that is Amazon. There is different kinds of services through which you can run Kubernetes on Amazon. There's EKS, and there is, you can run it through E2 instances, which we'll be doing today, and there's different things like that, right? And companies like Big Basket, Amazon, Grofers, everybody is using Kubernetes for their infrastructure because of its various features. Let's discuss those one by one. So the heavy usage around Kubernetes is heavily dependent on the fact that it is very, very, very useful. First and foremost thing that it does is it does service discovery and load balancing. So majority of the Kubernetes cluster, they communicate internally, but you can expose some endpoints to the end customer so that they can reach to your to your pods and stuff like that. So what it does is it allows you to have that segregation of load. It does this load balancing where you can have the traffic being distributed among different services so that there's not much impact on one pod and your services stay up. Other thing that it gives you is gives you storage orchestration as well. So there's different kinds of storages which you can use in Kubernetes, many instances, and majority of the people try using mtdir or persistent volumes as well, because persistent volume is something which retains the data even after if your pod crashes, right? And then there is something which is very interesting, which is automated rollouts and rollbacks. So let's say I have a Kubernetes service, right? So I have a Kubernetes uh, service or an instance running, and that is a web application, right? So I'm running a web application with, let's say, 4 replicas, so to manage my balance, to balance the traffic among them. Now what happens is I have a new version 2.0 which I want to roll out, but if I wanted to do it some other way, I had to take my website down. But what Kubernetes allows you to do is you can push your rollouts or your updates simultaneously in round robin fashion, where everything's get updated without having any kind of a downtime. So that is something very good. And the other advantage of doing that is, let's say if my new deployment is had some failure with respect to something, and there was some bug that we didn't see coming right beforehand. So in that scenario, what you can do is you can push for a rollback, so it will move back to the previous version instantly without having to actually experience a lot of downtime, right? So that is something again very good given by Kubernetes itself. Other thing which is very useful about Kubernetes is its self-healing ability. So as we were talking about, so let's say I have 5 replicas of something, right? If I'm creating a deployment, I have 5 replicas of an pod which is managing all of the workload which is coming, right? Now I have 5 replicas, and this 5 replicas, let's say one of them, like if I have 5 pods and one of those pods crashes or something happens to it, what will happen is in general scenario you won't have anything up, right? Because it has crashed, there is nothing right. But what Kubernetes does is it replicates, it heals itself. So it basically restarts any pod that crashes or any pod that you do not need or is going off. It will restart it for you. It will create a new pod on its own, even if you do not basically have to create a new pod. If it is crashing at some point of time, Kubernetes will actually automatically do it for you. So that is another advantage that we get from using Kubernetes. And finally is the secret and configuration management. Secrets are basically something which you use to pass sensitive information like passwords and authentication keys and stuff like that. And Kubernetes allows you to do that as well. So it gives you too much advantage, and it makes your deployment so much easy. It removes downtimes, has too much advantages. So that is the reason why so many people across the world are now using Kubernetes. So let's move along and talk about the architecture of Kubernetes, right? So the next topic on our hand is the architecture of Kubernetes. So in the architecture of Kubernetes, we basically have very few elements. When you're talking about it, it follows a client-server architecture wherein we have a master installed on one machine and a node on separate machines. So when you are configuring it, you can think about a master and a slave architecture, which is there. And you can see it better in this image right here. So you have 2 worker nodes here, and they are attached to this one master node. Now master node has its own separate things like API controller, control manager, scheduler, and then there is this command line interface, which is the kubectl, through which you can communicate. And apart from that, you have something called an etcd. Etcd is something that stores configuration information which can be used by each of the nodes in the cluster. It is highly available key value store that can be distributed among multiple nodes as well. So it is only accessible by Kubernetes API server, as it may have some sensitive information, and it is a distributed key value store which is accessible to all. Right. Other than that, we have API server, which is Kubernetes API server, which provides all the info operation on the cluster using the API. API server implements an interface, which means basically different tools and libraries can readily communicate with it. There is something called as kubeconfig, which is a package along with the server side tools that can be used for communication, and it exposes the Kubernetes API. So that is the job of the API server that you are seeing here. Other than that, we have control manager, which is responsible for most of the collectors and that the regulators of the state of the collectors, and whatever the task is being performed with respect to that, it is something that controls everything which is going out there. And then there is scheduler. So as the name suggests, it basically schedules the one of the most key components of Kubernetes master service is this scheduler. It is a service in master which is responsible for distributing the workload. So that is that. And it is responsible for tracking and the utilization of a working load on different cluster nodes, and then placing the workload on which resources are available and who all can accept the workload. It divides it based on that. In other words, basically this is a mechanism responsible for allocating different pods to available nodes, and the scheduler is responsible for workload utilization and allocating the pods to a new node. So you have a lot of different nodes. You can allocate your so basically whenever you spawn a new pod, right, so you do not define particularly that I want it to go to this node. You can do that, but you generally don't do it. You can do it in scenarios where you have some nodes which are having specific GPU services or some specific hardware. You can assign it to that, but generally we just launch a pod, right? So you have n number of nodes, so it's the job of the scheduler to decide which node will that pod go on. So that is the job of the scheduler. Other than that, we have few things in the worker node as well. We have the kubelet service, we have the kube proxy, there is pods, and there is Docker. So the pods will have Docker containers inside of them and stuff like that. So that is the basic idea behind the Kubernetes architecture. So as you can see, so this is what basically we are looking at when we are working with Kubernetes architecture. Now let's talk about some important concepts inside of Kubernetes, which we're going to be seeing in this hands-on session as well. So to start off, let's begin with pods, which is the most basic unit in Kubernetes. So a pod is the basic execution unit of Kubernetes applications, and it is the smallest and the simplest unit in the Kubernetes object model that you can create or deploy, right? A pod represents a running a pod which is there, which it runs on your different nodes on your cluster. So a pod is basically used for content management of system files, data loaders, and local cache. So all of the configuration is there with respect to that. That is there inside of a pod. You have different kinds of containers inside of a pod, which you can have to pull different kinds of images. So it has all of the logs and the checkpoints, backup, compression, rotation, snapshotting, and everything. It can be used for that. You can use for fetching data as well. And other than that, it has a different configurations with respect to proxies, the bridges, the adapters, the controllers, managers, configurations, and updaters, and everything with respect to that. So whatever you're going to be launching, you'll be launching inside of this pod, and this pod has a particular YAML file. We'll be discussing that once we get into the hands-on section. So for now, just understand that you have Docker containers, right? Your Docker containers can have different images of things where it can pull images of a website or something like that, and in there, or an OS for that matter. And this is written to a Kubernetes pod, and that pod can be deployed as a deployment, or it can be running. It could be running as just as a pod, and different things like that. You can get inside those pods and make changes to those Docker containers as well. So that is something there. Let's move along and talk about the other thing which is very important. So you have something called as a deployment, which is very, very important in Kubernetes, and we'll be discussing this with the help of an hands-on. So basically deployments are upgraded in higher version of replication controller. So those of you that do not know, replication controller is a concept inside of Kubernetes that basically helps you create the replicas of the pods or application sets which are there, but this is a higher version of that. So these basically manage the deployment of replica sets, which is also the upgraded version of the replication controller, and they have the capability to update the replica sets, also are capable of rolling back to the previous version. So basically your deployment is something which let's say I have to create 5 set of pods, right? And I always want 5 set of pods to be up till the end of the time when I don't want it, right? So the job of deployment is to make sure, like if I have described I need 5 pods continuously running, the job of deployment is to make sure that 5 pods are always running. If one of my pod goes into pending state, or it crashes, or something happens to it, it's the job of the deployment to create or launch a new pod and delete the older one, right? So that is the basic job of a deployment that it does. So it basically helps you control the replicas which are there, and it makes sure that your self-healing process is always there, and ensures that there is no downtime to your particular deployment, right? So let's move along and talk about the different features which are there inside of deployment. So there is this feature of match labels as selectors, and we have a new controller in Kubernetes master called as deployment controller, which makes it all happen basically. So it has basically the capability to change the deployment in midway, and that is something which allows you to do rolling updates and automatic updates and stuff like that. So rolling update is something where you have, let's say I have 5 pod replicas and I'm pushing an update. So basically what it'll do, it will take down 1 pod at a time, and make sure it is replaced with the newer one, and it's this way it makes sure that whatever the requests are coming, there is no downtime whatsoever, even if you are pushing an update, right? So some will be pointing to the older ones till they are replaced with the newer one, and as soon as the newer ones are ready, and all of them start pointing to the newer ones, and you have an update inside of seconds, right? So that is what the deployment helps you in. And then there is something called as services. Now services can be thought as a set of logical posts. So what does that mean? So let me explain this with the help of an example. So in Kubernetes, what happens is there are different 4 kinds of services are there in Kubernetes, right? So there is cluster IP, there is node port, there is load balancer, and there is external namespace, right? So cluster IP is basically a by default service which is there in Kubernetes. That is how Kubernetes internally communicates with itself as well. So if I just randomly have attached Kubernetes and I search for services, I'll see a Kubernetes service running by default, right? That is a cluster IP service. So what happens is this is basically an internal communication between the pods, right? So if I'm creating, let's say if I want to create a website and I want to host it somewhere outside, I need to have something which exposes my endpoint. And that is what a job of a service can do. So basically, let's say if I'm the end user and I want to click on the website, I don't actually know where the code is there, right? I don't know where it is actually located, or where it is happening. But what service does is basically creates a pathway to you where you have to hit the IP of the service, and service will basically navigate you to the pods. So let's say there are 4 replicas, service will take you inside, and from there, whichever the pod is responsible to be responding to you will be responding, and that is how you basically communicate with the pod without actually knowing where the pod is. So basically, it gives the layers of abstraction on top of every pods, which basically provides a single IP address and a DNS name by which the pods can be accessed. And with service, it is very easy to manage load balancing configuration, and it basically helps you to scale the pods very easily. So that is what Kubernetes is very helpful for. And service is basically a REST object in Kubernetes whose definition can be posted to Kubernetes API server, which we were talking about in the architecture section, which is something which is responsible for all of the APIs inside of Kubernetes. So on the Kubernetes master, it can be used to create new instances. So the set of pods targeted by a service is usually determined by a selector. So whatever pods that you are going for inside of a service, you can define it by selectors. I can give you an example for this. As you can see, the selector inside of this is my app, as you can see in the example here. So you can see the version 1 and kind is given service. This is something what basically a YAML file looks like. This is all the overall look of the YAML file. So let me quickly jump into the hands-on section now, and let me show you a demo on Kubernetes. So what we have done here is we have basically created our own we have created an own cluster. So we have a master and a node in it. Let me show you real quickly. kubectl get nodes we can do to find out how many nodes are there. So I have one master and one slave, which is ready. So we have created this configuration. So if you want to create this configuration or want to know how to do that configuration, we have previously released a video on it. You can ask that for right now in the chat section, and they'll be assisting you with the link. And if you are watching it later on, you can comment it down below, and the support team will get you the actual installation link. So the installation part is there. So we have a cluster ready. So what we are going to do now is we are going to create a pod, and then we're gonna delete that pod and see if the pod is deleted. Then we'll create same pods with the help of a deployment and delete them and see if they are still working, and then we'll be seeing what our service looks like. And basically that will be all we are going to do in this hands-on section. So that is the agenda for this one. So let me talk about the YAML files first. So if you're creating a pod, what will your YAML look like, right? So if you are interested about finding out more on the architecture and the YAML files, if this is fairly new to you, you can ask that in the comment section as well. So there is another video on it where we have in depth gone about how to create the YAML files and stuff like that. So you can go ahead and learn there itself. So basically for now, just understand that this is how a YAML file looks like. So you can see the API version is v1 and the kind of the version is pod. There's metadata, and the name is of the pod is Intellipaat, and the name inside of the container is SISE, and the image that we are pulling is HSHAR web app. This is a Docker container which we have created previously, and the container ports have been mentioned. All right, so how do we go ahead and create that in Kubernetes? So what we're going to do is we're going to do nano pod1.yaml. We'll be creating this YAML file. So let me quickly, it's very important that you manage this particular indentation that we have given here, right? Like there is one space after two spaces after every this double dot, and one space after this hyphen, because that is how you basically define the properties inside of it. So if you're interested in that, you can ask for the video, they'll be happy to assist you. So now we're going to be creating a pod real quickly. So we're gonna paste this pod configuration, I'm gonna save it, and let me just quickly create this. So for now, just let's just check if we have any pods running right now. So we're gonna do kubectl get pods, right? And you can see there is no pods in the default namespace. Now we're gonna create our own pod. So kubectl create -f pod1.yaml, right? I'm gonna create that pod real quickly, and as you can see, the pod Intellipaat was created. So let me quickly jump on and see how that looks. kubectl get pods. As you can see, our Intellipaat pod is running right now, right? So we can get inside of this pod, find out different details inside of it. We can use this command kubectl describe pods, and I'm gonna give the pod name, which is Intellipaat. So you can see the image that is being pulled, the container ID and the ports and the host and everything with respect to that has been mentioned here. If the image is pulled successfully, and whatever is there with respect to that, if it has secret volume, everything has been detailed in detail described in this one as soon as you use the kubectl describe command, right? So this is how you create a pod. Let's see if we can delete this pod real quickly. So let's clear this screen for a while, and kubectl get pods, kubectl delete hyphen delete. We can delete the entire file itself, through which we have created, and through which that can also be deleted, right? Pod1.yaml. Let's not do that. Let's just delete this pod, delete pods, and we're gonna get the pod name, right? And with that, you can see the pod has been deleted. So that is how it'll take a couple of seconds to finalize it, and we're going to wait for that. And meanwhile, let me show you real quickly how the deployments. So this is the in one YAML file you can define multiple things, right? So in this one we have defined only the pod, but in this one we are creating a deployment, and this part from this pink arrow up here to this pink arrow down here, there's a deployment YAML. So this is the version we are pulling here is app/v1. You can see here that was a different version. His API version was different, and you can see that was v1. This is app.v1, so you have to take good care of that. And then there is the strategies to recreate. Then there is this name nginx, and then there is matching labels. You can have different number of replicas. You can have 2 replicas here as well, and you can have 2 replicas of the pod running. So if I were to change this one to 2 replicas, it will create basically 2 pod instances for that. And the container's name has been given here, and below it, sorry, we have a service of the type load balancer, right? We are creating it on the go itself to save a little bit of more time. So we have the nginx name, and the default namespaces is there, and you can see the name and the external port, and the type of the service that we are using is load balancer. So let's quickly just copy this whole real quickly. Let's see if our pod has been deleted. See, our pod has been deleted. So now what we're going to do is nano. Let's create dep.yaml. So we're going to call it deployment, and let's quickly paste it real quickly here, and everything has populated. Let's go outside. So the command for running it is kubectl create -f dep.yaml. So this has basically created a deployment for us and a service which is called nginx. So the advantage of this is right now we'll have a kubectl get pods. So we'll be having this pod. 1 second. Yeah. So we'll be having a replica of this pod which is there, right? So you can see this one pod is there. Just keep the eye on the name, right? So it is D6TGF in the end. Now let's see what happens if I delete this pod. What will happen? So kubectl delete pods and the pod name. Click enter, and you can see the pod has been deleted. Just wait for a couple of seconds. Now what will happen if we get pods? Now, according to the self-healing service of Kubernetes, we should have another pod running of the different name, right? So you can see it has created a new pod on its own, so there is no down seconds whatsoever. So you can see this pod was deleted and this copy pod was created because this is a deployment that we made. So the job of deployment is to make sure the pods are always up, right? So let's quickly see if we have created the services also. So kubectl get svc. So we have the type of the nginx service being created, but it is in the pending state. I think it is because of the slow internet and service today a little bit slower on the server's end. So let's quickly do one thing and get inside of a pod and see how that happens, right? So kubectl exec -it, and then your pod's name. We are going inside of this pod, guys. So let's see what's there inside of this pod. How does it look like? So -it, and to get inside of it, -- space bin/bash. We made a spelling mistake. Let's quickly remove that and go. So you can see we are inside of this pod now. Let's see what all is there inside of this pod. So ls, as you can see, there is different folders inside of this pod that we can go. So I am going to show you what basically nginx, where the nginx HTML file is there. So cd user, then ls again, then inside of this folder you can see all of these folders are there. So cd share, and then we're going to do another ls, and you can see a lot of different things is there. We can see the nginx is the folder that we want to go to. Then we're going to go ls again, and you can see there's an HTML folder. So we're going to go to the HTML folder and see what is inside of it. So if we do cd and and see this HTML file. We are inside the HTML folder, right? So cd ls. So let's quickly see what is there in that index.html. As you can see, this is the HTML code inside of that service. So if we are going to create that service and in the endpoint is exposed, this is something what we'll be seeing as export. So if the service is not running right now as of now, but if it was running, we'll be seeing this one. So what you can do is you can change this code and you can call it internally the service, and you can see how that works, right? So let's quickly change this. So the way to change it is cat, and you make this and index.html. So now you can basically change whatever is written inside of the file. So we have a sample code ready here, which just says Intellipaat, and if the internet was properly working, we'd probably see that. Let's see if we can get it up and running. And I'm going to paste it real quickly, and we're going to be saving that. And let's cat it again to see if that works. As you can see, here it is, the end of the section, and we have Intellipaat. So to get out of this, just press Ctrl D. Now we are back in the kubectl. So let's see if the service is up and running. The service is still pending. So what we can do is we can curl the internal address and see what is happening. And if I curl it, I should get the above given Intellipaat thing, right? So let's quickly do that. As you can see, it gives this in the background. So that is about the hands-on, guys. So let's quickly jump back to our PP session and get ahead and find out what we can do to learn more, right? So towards the further learning section, so where you can go about and learn more. So we at Intellipaat, we are concerned about creating free content all the time. So we understand that an investment in knowledge always pays the best interest. So we understand that, and so that you need a lot of materials online. So we provide a lot of free content for you to start learning Kubernetes. So if you're interested in learning DevOps, you can start ahead and learn with the Intellipaat blogs. And if you're someone who is more interested in the YouTube tutorials, you can go ahead and check all different things in our YouTube channel. We post a lot of different content about Docker, DevOps, and different things about it, like Kubernetes, data science, and different technologies. So if you can interested, you can go ahead and learn it there. And if you're interested about learning about Kubernetes, let me show you the courses that we offer real quickly. So if you go to our website and search for Intellipaat right now, and you go to the website and you search for Kubernetes, you can see this Docker certification training course on our website. So this is a master's architecture program, and this is in collaboration with IBM. So let me show you this course real quickly. So what basically happens is we have a once you finish this course, you'll be getting a certification with IBM. So this is what basically a certificate looks like. So this is in collaboration with IBM, so you'll be getting an IBM based certification as well. Apart from that, what we offer in this course is 42 hours of instructor-led training, 33 hours of self-paced training. And our instructors are, again, industry experts. These people have been working in the industry for years and years now, and we check their background and we check their certifications as well. And these people teach you with their experience. So whatever is being done in the industry right now, you are taught with those experience as well. And apart from that, everybody knows that in the software development world, projects are everything. That's why we give you 60 hours of projects, works, and exercises, so that you can put them on your resume and have your resume have that edge and get you ready for the industry is what we aspire for, basically. So having those hands-on project and having those exercises and hours will basically help you be proficient with the DevOps things, and you'll be ready for your job certifications as well. Apart from that, we give you flexible scheduling and lifetime free upgrades. So flexible scheduling, basically we have the classes on your leisure, so it's according to the weekends or the weekdays that you require, and based on that you can have classes on that, and you have a lifetime free upgrade. So let's say 1 year from now you are forgetting some Kubernetes concept or something has changed and you're not very sure about it, or you are forgetting something about the architecture, you don't have to worry about it. You can come back to us, you can learn with us anytime that you want. Apart from that, you have this opportunity of 24/7 lifetime support. So basically, if you have a doubt at, let's say, 4 a.m. tomorrow while learning Kubernetes as to what is being done, you don't have to worry about it. All you have to do is reach out to our support team and they'll be happy to assist you with all the doubts that you have. So that is about this course, guys. So let me quickly jump back to the presentation and end this live. So with that, we have come towards the end of the session. So since you have been so good and stuck around me towards the end of this live session, I'm giving you this coupon code which will give you flat 30% off on any of our courses. So all you have to do is go to the YouTube code, YouTube, and you have to go to our website and type YOUTUBE30, YouTube 30, which will give you flat 30% off on our courses. And that is about it. So if you have any questions with respect to this session or any of the sessions that we had, you can keep the numbers are on your screen. You can call us at any time that you want. If you want to get personalized suggestions as to what has to be done with respect to your resume in order to land those better jobs, you can reach out to the numbers on the screen. And again, you will be connected to our course advisors who are industry experts, and they know what the industry wants, and they will help you out personally based on your resume so that you do not have that problem. And if you have any other queries, you can put them in the comments below and we'll be happy to assist you. Thank you so much for tuning in, guys, and I'll see you in the next one.